Hi everyone. So in the last tutorial of tree series, we talked about how to build a binary search tree. Now as a part of this tutorial, we're going to discuss about the pre-order traversal. So we're going to perform the pre-order traversal operation with the help of recursion. So to do this, we have to follow some steps. The first step is we have to print the root node if it is not null. The second step is we have to keep printing the left node of the root node until the reference of left node will not reach to the null. The third step is we have to keep printing the right node of the root node until the right node reference will not reach to the null. So as you all know, recursion will comes with its base case, and in this pre-order traversal, the base case is once the current will be pointing to null. So in that case, the recursion will terminate and backtrack when it reaches to the bottommost of the binary search tree. Now, let's see how pre-order traversal implementation with the help of recursion works internally. So we have already created a binary search tree with the help of these elements, and we'll start traversing from the root node of the tree towards the left node of the root node, and we'll be keep traversing until the left node of the root node reference will not point to null. Once it is pointing to null, it will backtrack to the previous node, and it will be checking the right hand side node whether it is null or not. So likewise, backtracking will be happening on each node, and it will be checking the right hand side node. So once all the traversion for the left nodes of the root node is done, so control will be backtrack to the root node. So same steps will be applies to right node of the root node, and once all the elements of the right node of the uh, root node are done, so the control will backtrack to the root node. So that is how the implementation of this pre-order traversal operation will work. So let's see by looking into dry run strategy how it is happening. So we'll start traversing from the root node. Main method will call the method which has the logic to perform the pre-order traversal operation with recursion. So it will add 50 into stack first, and it will print the 50 into console. Now uh, it will make a call to 35, sorry, left hand side node, and it will be checking whether left hand side is null or not. If it is not null, so the 35 will be added into the stack, and it will also print it on console. So likewise, it will be keep checking for left hand side, which is 20. So it will be, as it is not null, it is pointing like we have reference 35, left is pointing to the 20. So it will be making a call, and that call is basically taking care of adding that element into stack, and printing that element into current element into console. So again, 20 will be looking left hand side, whether left node is present. Yes, it is present, so it will making a call, and 10 element 10 is added into stack, and it will print on the console as well. Now we are at this point where the left node reference and the right node reference is pointing to null. So in that case, in stack also we will have null, like 10 is pointing to null here currently. Now we won't be going further because there is no any further reference as it is pointing to null. So it means we'll be routing back to 10, as left hand side and right hand side is both done, because there is only a left call and right call in the recursion method. So there is no any further implementation. So it once that is executed, so it will return control back to 20. If you could execute it, so we have 20 now. Now left hand side of 20 is executed. Now it mean only right hand side is pending. So right hand side will be making a this 20. Currently we will be checking whether the node 20 right reference is there or not, whether it is pointing to null or not. It is not pointing to null. In that case, we will be making a call to this right node, and we'll be adding 30 into stack, and along with that we'll be printing 30 on the console. So now 30 left node and right node both are pointing to null, so it will be adding null into stack, and then it will backtrack to 30, as both are implementation is both left and right of the 30 is executed. So nothing is pending to execute. Now it will return control back to 20, right? It means now we have to check whether 30 right, left and right is done or not, because only one line is pending. uh, it was pending 30, like right hand side of the uh, 20 node which we have executed. Now the control will return back to 35. So if you could execute it, it will point to 35. See now, uh, 35 only left node is executed, because only there should be a two lines. There is a two line. One is making a call to left hand side, and other is making a call to the right hand side, right? So left hand call is of the 35 is executed. Now right hand side call of the 35 is yet to execute. So now it is making call to right hand side, right node of the current node, that is 40. So while making a call, it will adding the 40 into stack, and then printing it into console. Now along with that, it will be checking whether 40 is pointing to any left node or not, but there is no any left node or right node. Both reference are pointing to null. I have not added the same way in under the 40 node because of the very less space. Even that is not even there for 52 because of not having enough space. So in that case, both reference, that is left and right reference of the 40 is pointing to null. So if you could see, it is pointing to null in the stack as well. Now it will backtrack to 35. See, it is returning, it is backtracking to 35. Now both of the node of the 35 is executed. It will backtrack to 50, that is root node. Now all the left nodes of the root node are executed. Now it is the backtrack uh, control is backtrack to 50, that is root node. Now we have only 50. It means the right hand side is yet to traverse. So it will be making a call towards the right hand side. So right hand side it's 60, so it will making a call and adding 60 into the stack. Along with it will be printing it on console. Now in the right hand side also, the first step is to check left element is present or not. If it is present, then make a call to left hand side. So left node is present, it will making a call to left hand side and adding 52 into stack and printing it on console. So the 52 left and right node both are pointing to null. So it will add null into the stack. Now once it is null, so we have a base case. So any of the node is pointing to null, then control should uh, backtrack to the previous node. So in that case, it is pointing to null. So control will backtrack to the previous node, which is 60, right? Now 60 is basically left hand side of the 60 node is executed. Now right side of this right node of the current node, that is 60, is yet to execute. So it, as it is not pointing to null, it is pointing to 70. It means 60 will make a call recursively. It will make a call to the same method by passing the 60 reference, that is nothing but 70, and that will be taking care of adding the element into stack 70. Now 70 left and right both nodes are pointing to null. In that case, uh, basically we are making a call to another method by passing null, right, for left hand side and right hand side. But we have base condition which will looking into the like if the reference of left hand side, if it is null, then return control back to uh, previous node, that is 70, and 70 then execute the remaining line of the code, that is making a call to right hand side. If it is not pointing to null, then execute that implementation. If it is pointing to null, then return control back to previous node, that is 70. And as both are pointing to null, so return back control back to 60. Now if you could see, it is pointing to 60 only. Backtrack controls backtrack to 60, as 60 left and right hand side both are executed. So control will return back to root node, that is 50, right? Now that way we have executed all the nodes, left node of the root node and right node of the root node. We have traverse and we have pre-order traversal output. So this is how we will be executing, and internally it is performing the operation. Now let's see how we will be performing the same operation with the help of backend code. So let's get started with the backend implementation. So I have already created a class called pre-order-traversal. Inside this class, I have mentioned three things. The first one is input of elements, which we use to build a tree. The second thing is a tree itself. And the third one is expected output, which we are expecting from this program. So inside this class, we'll be writing one method, which is performing the pre-order traversal operation with the help of recursion. So let's get started. Static void, the method name will be pre-order traversal, which is expecting current of node type. So inside this method, we'll be performing three operations. One is printing the current node value by using current.data, followed by arrow symbol. The second thing is we'll start traversing from the left hand side of the root node. So current dot left first. Once that is done, then current dot right side, right? So these lines, two lines, will be take care of traversing each node of the uh, tree, whether it is left node and the left node is having right child or left child, and then this line is taking care of printing your all the elements in the pre-order fashion, right? But at some point of time your left or right value comes with null value, so this current value will current reference will be holding the null value, which will throw null pointer exception at this line. So to avoid that, each recursion will comes with its base uh, case. So in our program, base case will be objects dot is null. If this current is null, so return control back to the caller method, right, or previous node. So that implementation is done. Let's write main method to test whether uh, logic is working fine or not. So inside this class, inside this method, main method will be performing two things. One is building or build tree, and the second one is pre-order traversal, right? This is called pre-order traversal. So let's finish first one. So we won't be building tree in this program because we have in the last tutorial of tree series we built this tree builder, which is taking care of building your tree. And in whenever we need to perform any operation on tree, we just need to call this builder, and the tree building part is done with the help of this pre-builder implementation, right? So let's call var root tree builder dot build, right? And then second part is call pre-order traversal. So let's call pre-order traversal by passing root as a node, right? Now we'll be executing this program, verifying whether it is printing the expected output or not. All right, let's compare this output with our expected output, which we discussed while building a program. There may be a difference of arrow that we won't be considering. So yeah, 50, 50, 35, 35, 20, 20, 10, 10, 30, 40, 60, 50, 70, right? So it starts from 50. It go to left hand side first, 35, then 20, then 10. Then it will return back, control return back to 20, then it will print 30, right? And then after 30, control return back to 20, and then 35. So in 35, we have not traversed right inside of the 35, which is 40. So after 30, it will print 40, and then there is no any further node of 40. So it will return back to root node, right? And root node right hand side is yet to traverse. So it will traverse to the right hand side. So it will be printing uh, 60, which is this one. After 40 it will be printing 60 directly, and after 60 there is a left node which is 52, so it will be printing 52, and then there is nothing next to 52, there is no left and right, so backtrack will be uh, going back to the previous node, that is 60, and right hand side is of the 60 is yet to traverse, so it will call 70 and it will print 70, and then control will return back to 60 and then 50, right? So this is fine, right? So idea is basically with the recursion how you want to use recursion, right? See, right now we are firstly printing the value and then calling the left and right node. So as we compared the expected output and the output which this program is producing, that is matching to each other, so our program is working fine. We are done with this program. Thank you so much for watching this video, and stay tuned for another videos of the tree series. Thank you.